MapReduce is a programming model by Google to handle very large amounts of data quickly and efficiently. It processes massive data sets like web pages or social media activity using many computers together, not just one powerful machine. The idea is simple. Break work into smaller chunks, process them in parallel, then combine results. Imagine you have billions of lines of data, like all words from every web page on the internet. Counting how many times each word appears on one computer would take a very long time. MapReduce divides this into two main steps, map and reduce. The map step transforms data into smaller, manageable key value pairs, like word 1. Each mapper works on a portion of data, outputting intermediate results. The reduce step groups these intermediate results by key, then performs aggregation, like adding up counts. The final output is the total count of each word across all data. In short, map breaks down and labels data. Reduce combines and summarizes it. Think of MapReduce like a school group project, counting words in every library book. The teacher assigns each student a few books. This is the map step, breaking a large problem into smaller tasks. Each student reads their books, writes down each word with a 1, then gives their list to the teacher. The teacher collects lists, groups same words, and adds up counts. That's the reduce step. The teacher produces a final list like cat, 42. This divide and conquer principle powers MapReduce. Computers running MapReduce follow a similar pattern, storing data in a distributed file system like HDFS. Splitting. The big data set is divided into chunks, each a few hundred megabytes or gigabytes. Mapping. Each chunk is processed by a mapper that extracts information and produces key value pairs. Shuffling and sorting. The system groups all data by key, ensuring identical keys end up together. Reducing. The reducer combines each group of key value pairs to produce a single result per key. Output. The final results are written to storage, ready for use or analysis. Programmers don't worry about machine details or failure recovery. The MapReduce framework manages it automatically. Before MapReduce, analyzing huge datasets required specialized, expensive hardware. Google's innovation allowed ordinary computers, sometimes thousands, to process data in parallel. If one computer failed, the framework reassigned its task, making the process fault-tolerant. This inspired open-source projects like Apache Hadoop, bringing MapReduce to everyone. Small companies, universities, and startups could now process terabytes of data without supercomputers. The classic word count problem explains MapReduce. Mappers count words, and reducers sum those counts. Companies use MapReduce to analyze millions of user interactions daily, counting clicks or time on pages. Streaming platforms like Netflix use MapReduce to process user preferences, finding patterns like users who watched X also liked Y. MapReduce can clean or convert large data sets, like transforming logs into structured data. Scalability. It handles petabytes of data by simply adding more computers. Fault tolerance. If a node fails, the job continues without losing data. Simplicity. Developers only write mapping and reducing logic. The system handles the rest. Cost efficiency. Runs on commodity hardware, not expensive supercomputers. Parallel processing. Tasks run simultaneously, greatly reducing time. While powerful, MapReduce is batch-oriented, not designed for real-time analysis. Disk usage. Each step writes data to disk, slowing it compared to modern in-memory frameworks like Spark. Complex debugging. Finding and fixing issues in a distributed MapReduce job can be challenging. Rigid workflow, best for tasks easily divided into independent chunks. Interactive workloads may not fit. Newer technologies like Apache Spark have improved upon MapReduce, but its original idea still shapes modern data processing. These newer tools keep the same conceptual model, mapping and reducing, but run faster by keeping data in memory. MapReduce was a turning point, democratizing large-scale data processing for ordinary machines and simple code. In summary, MapReduce is like an assembly line for data. Map, workers break down and label raw material, while reduce, workers combine labeled parts into a final result. It hides distributed computing complexity, letting developers focus on logic. By turning a data mountain into manageable pebbles, MapReduce transformed how the world handles information. It laid the foundation for today's data-driven systems, proving large problems can be solved piece by piece.